Okay, in this video, I figured it was easier for me to create a video now than to show you guys a whole bunch of screen captures. I want to have a look at how to create the X-bar and error charts when you're given summary data, which is the case in question 1 of assignment 7. So far in the course, the problems we've had, we've been given the raw data. So say you got sample 1 and somebody went to the line and they collected 5 items. Then you've got the 5 different measurements for each of those, and Minitab would calculate the mean and the range itself and then do the control chart for you, do all the magic. But if you go in and try and do an X-bar and error chart with summary data, Minitab won't do it. Imagine that. All right, so I have all my data here, and there are 24 samples. We have a mean, we have a range for each one. In order to proceed with the question really is all about, is the process capable? But before we can determine if it's capable, we have to know whether the process is in control. So that means we need to generate X-bar and error charts. So first thing you got to do is calculate the center line on your X-bar and your error charts, and of course the upper and lower control limits. So go in and sum up all these numbers you got in C2 and divide by 24, and you'll get your X double bar, and you would do the same thing for the R. Once you have your X double bar and your R bar, you then go calculate your upper and lower control limits, and then you're ready to do the graph. Okay, to do the graph, you can use the scatter plot or a time series plot. I think probably scatter plot may be slightly easier, but doesn't really matter. All right, I want a simple scatter plot, but I do want it to connect the dots because that's typically the way we would see a control chart. All right, now, because there's a whole bunch of lines here, I can do both my X-bar and R chart at the same time. And on the y-axis, I want it to plot the means against the sample number on the x-axis, and do the same thing with the range. So range on the y against sample number. And say OK to this. And I get right here my X-bar chart, and I'm going to move my window over here a bit and you can see the R. All right, so first of all, let's focus here on the X-bar. Now, all this thing has done for me so far is to plot each of my 24 means. I have no idea if this is in control because we didn't tell it what the control limits were. Now, you would have already calculated these. Once this chart is generated, we're going to go in, hit the little down arrow here. We're going to edit the graph. And you can do a whole bunch of stuff when you edit graphs in Minitab, but right now what I'm interested in is adding some reference lines. Okay, on my X-bar chart, I want to give it the center line, which I've calculated to be 34.0042. Give it the upper control limit, which I got as 36.721. And the lower control limit is 31.287. All right, say OK to that. And okay, yeah, well, I could say OK, but by the way, if you wanted to get fancy, you could double click on these numbers. And this number represents my upper control limit. This one is my center line. And last of all, I've got my lower control limit right here. All right, now I'm satisfied, say OK. So here's my control chart. And from my control chart, I can see if I mouse over that at sample 12 and at sample 15, my process is out of control. These 2 points are plotting outside of the control limits. So before we can decide on whether this process is capable, we are going to have to remove those 2 control points at least. I don't know yet what's happening on the R chart. We also got to consider that. But right now, 12 and 15 are problems on the X-bar chart. All right, if I move my window over here now to the error chart, again, I would hit my down arrow. I'm going to edit, and I'm going to add reference lines. And on the what did I calculate things to be? Okay, first of all, the center line is 4.7083. The upper control limit is, where is it? Upper control limit is 9.953, and the lower control limit is 0. Say OK, and I'm not going to get fancy, I'll just leave it. And OK, I got no points plotting out of control. So coming back to my X-bar chart, I am now going to want to redo my calculations by removing subgroups 12 and 15. All right, so I've done that, and you should have done that. Remove those. And now, if I come back in, I can use this chart I've already generated. Again, I'm going to edit it. And when I edit, I got to get rid of these old lines now, because these are not going to, I'm not going to use them anymore. Now, see how there's a little box right here? So I got that highlighted. If I say delete, okay, it's gone. Same thing there, and same thing here. All right, so I got rid of the old limits. I'm now going to put in the new reference lines that I calculated after I removed subgroups 12 and 15. So the center line is 33.65. The new upper control limit is 36.2465, and the lower is 31.0535. Okay, say okay to that, and okay. And my limits have tightened up, and there are no other points out of control. There's my 12 and 15, but, you know, we've removed them from the calculations. So that looks good. Now, in order to calculate your process standard deviation, you're going to need to see what's happening on the error chart. And so coming back to my error chart here, if I just double clicked, or you can hit that down arrow and say edit. All right, I'm getting rid of these lines I had initially. And then once I recalculate by removing subgroups 12 and 15, what do I got now? I got a lower control limit of 0, so that stayed the same. My upper control limit is a bit tighter at 9.513. And my center line, R bar, is now 4.5. Say OK on OK, and everything is OK there. So now, in order to go on with the question, because the question was really, is the process capable? Well, in order to figure out whether it's capable, you need to calculate the standard deviation, but the standard deviation is based on R bar. So this 4.5 is the number you need now in order to proceed with the remaining part of your question. Okay, I think we're done here.